Hello everyone and welcome back to the Learn Python 3 series. In the last video we took a look at for loops and while loops and the different use cases for them and how we can use them to iterate over parts of our code. In this video we are going to take a look at functions and how we can use those to break off pieces of our code and modularize it. By the end of this video you're going to know everything there is to know about functions in Python, and to also be able to apply those concepts to other programming languages. So like I mentioned just a second ago, we can actually use functions to modularize our code. And what I mean by that is essentially that we can take pieces of our code that we might repeat a few times, but in different contexts, and break those off into their own code blocks so that we can call them multiple times throughout the code. Now that might not make a whole lot of sense now, but we're going to take a look at a lot of examples and then everything will make sense from there. So to define a function, essentially what we do is we have two parts. We have the def keyword, which is just short for define, and then we have the actual name of the function. So for example, if I wanted to write a function that returns the sum or, outputs the sum of 2 plus 2, just for an example, then essentially I would just name this maybe print sum. And then I have to follow it up with these parentheses. And we've seen these parentheses before. For example, like when we call the print function, we have these parentheses right here. And then in here we have like our message or whatever. So this is what's called the function signature. And essentially it's just this line right here. It's just where we're defining this function. Now we need to, just like if statements and for loops and while loops, have a colon here to signify that we are starting a block of code. Then our code indents, and then whatever we have in here, this is called the function body. Essentially everything that we have inside of this function. So if I said before that I wanted to print out the sum of 2 plus 2, well, we all know how to do that. I can just print out 2 plus 2. Now I would like to emphasize here that this is not 3, 2, 1. Now I'd like to emphasize to everyone here that this is not actual code that you would really write in a program. So I don't encourage you to do this. This is purely for an example, and we're actually going to build on this later on throughout the video, but just bear with me while we kind of go over the syntax here. I'm going to go ahead and give us some space up here. So we've defined our function that is going to print out the sum of 2 plus 2. Let's go ahead and run it and see what happens. I'm going to go ahead and save this and hit the arrow at the top. So we've went ahead and defined our function here that is going to output the sum of 2 plus 2. Let's go ahead and run this code and see what happens. I'm going to hit the arrow at the top here and let VS Code run my script. And you're actually going to notice that nothing happens at all. And maybe take a second to think about why the code hasn't done what we wanted it to do. If you said that we never actually called the function, you would be 100% correct. So just like before, we actually have to call functions. So print is defined somewhere in the Python standard library, or rather the Python language itself. Even though it's defined, we still have to actually tell Python where we want to use the code at. So we have to call it. So just like print, what I can actually do is just print sum. And then just like when you call print or whatever, you need to have these parentheses here, and that signifies that we're calling a function and we actually want it to execute. If I go ahead and run this now, you'll see that 4 was outputted to the console. Now, just like print, we can actually call this however many times. There's no limit to how many times you can call a function. It's really just whenever you need to use that function in a specific context. Now, it might be hard to see that context in the case of printing 2 plus 2, but when you start to implement more complex functions like maybe formulas, calculations, or maybe you modify something and you have to take something in a certain context, that's when it would be more useful. But anyways, let's go ahead and run this and see what happens. If I run it, You see I got 4 printed out 3 times, not 4 times. And that was expected because we called it 3 times. So I'm going to go ahead and remove this. And that was really just to demonstrate how we can reuse functions to do something. So let's go ahead and make our function just a little bit more sophisticated. So if you're writing a real program here, chances are you don't actually want to print anything out to the console. So let's say that I actually want to store this value of 2 plus 2. So one way I can do that is by actually returning the value from the function. Now returning does 2 main things, and we're going to talk about those 2, but for now let's just focus on what returning does. It lets the function give a value back to us, and what I mean by that is actually something that is better demonstrated. So if I go ahead and print this function, because that is something I can do, I can go ahead and print this function out. Let's run it and see what happens. So if I print it, you're going to see that none. So first of all, actually 4 was printed out because that's what happens when you call the function. So we're calling it here. So 4 was printed. And then when we print out what print sum equals, we actually get none here. And that gives us a little hint to see what print sum is actually returning. So really what we can do is we can write this like this. And by default, every function that doesn't have a specified return value returns none. So let's go ahead and return this value of 2 plus 2 and see what happens. So rather than printing it out, we actually want to use this return keyword here, just like we saw just a second ago. So now rather than printing out 2 plus 2, I'm going to return 2 plus 2. And return is a keyword, not a function here. So we don't need to put parentheses or anything here. Now, sometimes you might just to make it a little more explicit, but for what we're doing, 2 plus 2 is very straightforward, so we don't need to do any parentheses or anything. So now let's return 2 plus 2 and then see what is output by this print command here. If I go ahead and run that, now you're going to see 4 was printed, which is weird because before it was none. Well, that's actually because, like we talked about, it returns none. Well, now we're setting that to the sum of 2 plus 2, which is 4. If I don't print this out, let's see what happens. Because before, when we had that print statement there, it actually output the value. But here, we don't have anything. So that's pretty important for a few reasons. And one of those is, let's say that this wasn't just returning the sum of 2 plus 2, but rather we were actually doing some sort of mathematical formula and calculating something important. Chances are when you have a big formula, you're going to be calculating multiple smaller parts, and you might want to store a certain part of that formula or something along those lines. So what I can actually do is I can store this result or this sum here into a variable so that I can do something to it later. So if I go ahead and take this print sum call, and maybe I just store this in like X or something, this is completely valid, and really what it's saying is whatever value is just returned from this function here, or 2 plus 2 or 4, you're going to take 4 and you're just going to set that equal to X. You can essentially think of this as if I just took this and just copied and pasted it there rather than actually calling this function. So now let's go ahead and run it, and nothing's going to happen again because we're not printing it out. But if I go ahead and print out X, now we get 4. And I can manipulate X however I want, just like it's a normal variable. So I could do X plus equals 2. And then now if I run that, we're going to get, oh, I got to print X again. Let's try that. Run that, and I'm going to get 6. And that's because I incremented 4 by 2. Well, we can actually do another thing with return, and what return does, similar to break, is it actually stops the execution of a function and breaks out of a function. So like break exits a loop at a certain iteration whenever you put that break statement there. Return is actually going to take whatever it's returning, or you don't even need to return anything, and then it's just going to stop the rest of the function right then and there. So to give you an example here, just about any smart development environment, VS Code or PyCharm or anything is actually going to let you know when something isn't going to happen. So for example, let's put some code under this return statement. So maybe here, I want to print X. It immediately grayed out. If I hover my mouse over it, it just says code is unreachable. And that essentially lets us know that because it's hitting this return statement, we're not going to be executing any of the other code. And if I run that, I can prove that here. The same thing is happening. I'm not actually printing. So more with returning, you actually can return more than one value or, piece of data from a function. So the way you do that, and it's essentially returning a tuple, is you just comma separate it, and then maybe I want to return 1 plus 1. So maybe here I want to do X and Y. So rather than doing X equals this and Y equals this, maybe I could do X equals print sum at index 0 because it's a tuple, right? And this is just a formatting issue here, so I'm going to go ahead and fix that. And then maybe Y will be equal to the second one, so this tuple here. So now I can, I'm going to remove this, and I'm actually going to print X comma Y here and run that, and we'll just get 4 and 2, just as expected, because we're getting 4. And then this comma says, hey, we're returning something else. So then we return 2. And then we catch those here. And this is a feature that is not very common in a lot of other languages. Python is one of the very few languages that allows multiple return values. So that's just something to keep in mind before you try and do this in maybe another language like Java. Now, let's make this a little more Pythonic. So what I mean by Pythonic is take advantage of language features that allow us to do this more expressively. So we're actually going to do X comma Y here. And Python is smart enough to know that when I say X comma Y equals print sum, then really what it's saying is take this 2 plus 2, since it's the one on the left of the comma here in this tuple, store that in X, and then whatever's to the right of this comma in the second item in this tuple, then store that in Y. And I could really have another one here, so maybe 3 plus 3, and I'm really just returning a tuple with 3 values in it. And then I go ahead and put Z in here. And then if I do XYZ here and run it, just as expected, 4, 2, 6. So this right here, where this X comma Y comma Z, and then it equals this function here, that's called variable unpacking. We're unpacking this tuple into these 3 separate variables so that we can do whatever we want with them. So that's a nifty little language feature of Python. So let's go back to our print sum here, just as we left it before, returning 3 values from it. Let's go ahead and actually get rid of that, and I'm going to put pass in here just for a second. So part of writing code is the idea that we don't actually want to hard code anything, or essentially, we want to make our code as dynamic as possible. So rather than writing a function that prints the sum of 2 plus 2 or even returns the sum of 2 plus 2, what would be immediately more useful is having a function that adds 2 numbers. So immediately I'm just going to name this add, and we want to take in 2 values that we can just store temporarily and, return a calculation or whatever we want to do. These are called parameters, and you also might hear the term arguments. They're interchangeable. But really what I want to do is I want to say, let's take a number X and let's also take a number Y, and then we're going to return the sum of X and Y. So I can say X comma Y, and it is comma separated here, and you'll see that VS Code, my theme and everything, italicizes these arguments, and it also grays them out because it says they're not accessed. Let's just write return X plus Y, and as soon as we access X and Y, you'll see that it's stopped being grayed out, and we have essentially used them. So now when we want to call this add function, I'm going to call add, and you'll already see that VS Code is highlighting for me that I need to pass it this X value. So I'm going to say, let's do 1 plus 1. So just like we had them in the function signature, we actually pass them in by comma separated values. And just like before, we can actually store this in a variable. So let's call this result, maybe. And then at the end, I want to print result. And I could also just print this function here, but just for the sake of demonstration. Let's run that and we will get 2. Now, you can already maybe see the beauty in having this not hard-coded anymore. And this is that now we've actually made add much more useful for different contexts in our program. So let's go ahead and say that we want to make a little bit of a more useful function here that we could maybe use in multiple places throughout our program. So I'm just going to use the example of the circumference of a circle. So if I wanted to turn this formula into a function here, what I would do is first I'd define my function and maybe call this circumference. So I already need to take one variable here, and that variable is going to be the radius because that's the only non-constant value in this formula, and it's 2 pi r. So r, I'll just say that's the radius. And then inside of here, I'm actually just going to return 2 times 3.14 times r. And that is the circumference formula right there. Now I can maybe say c equals the circumference, and let's get a circle of length 1. And then I will print out c. And if we go ahead and run this, then we will get the value here. And this is the circumference of a circle with the radius of 1. Now I can also pass in variables rather than hard-coded values or literals. So maybe if I have a variable called radius and I call that 1, I can just pass in radius here and the same result is outputted to the console. So we've talked a little bit about parameters, but we can actually do something a little bit nicer with parameters, and that's actually setting default values to them. So what a default value in a parameter allows you to do is actually prevent your user from having to pass in a parameter if they don't need to. So a lot of what this could be useful for is maybe a function that you don't have to configure everything, so there's a better default value. But if the user wants to configure that and change it, then they have the means to do so, but they don't have to. So maybe, for example, that I want to say if the user doesn't pass in a radius here, then really they can just maybe calculate the circumference of a circle with a radius of 1. So really, just like a variable, I can set r equal to 1 here. So now I'm eliminating the fact that I have to pass in a value for r. And notice how it's not giving me an error now if I just call circumference. And that is because I don't need to, because it already knows if I don't pass anything, then the default value is 1. If I go ahead and run this, we get the same result that we were getting before. But now let's say I would like to specify this value for r. Since r is the only parameter in this function, I can actually just put 2 in there, and Python is smart enough to know that I'm referring to the radius. If I run this now, we get a different value. I can also explicitly tell Python that I want to set r equals to 2. So I'm going to go ahead and do that, and we get the same result. Something to keep in mind is that you can actually mix default parameters and regular parameters. But when you do that, you have to keep all of the default parameters after the typical ones that you pass. So maybe if we have, I don't know, I'm just going to throw an example in here. Let's say that I wanted to add an x in here. We're actually going to get an error, and that's because we are passing a non-default argument after a default argument. So what it's telling me is that if I want to pass in an x, I have to do so before r. And then now, if I do that, and let's just, I don't know, we'll just add x. This isn't a real formula. Now what happens if I pass in 2 is you can even see if we hover over it that this is the function signature here. If I run it, we're going to get something just a little bit different, and that's because Python thinks because we didn't specify r equals 2, that we're actually just filling 2 in for x. So I can go back to r equals 2, and then we're actually going to get an error here because I still need to specify x. So I could just do 0 since we're adding it on. And if I run that, we're going to get the circumference that we did before. We've seen passing in arguments as non-default and default arguments. But what happens when we want to pass in an infinite number of arguments into a function? Rather than specifying, you know, you have like x, y, z, w, and then you know, just go down the line here. That's a whole lot to remember. let's say that there are a lot of things to configure here, then really we want to just let Python know that we are going to let it pass however many arguments the user passes to it, and then us, the developer, will be able to do whatever we want with that. There is a convention for this, and there are two types of infinite parameters in Python. There are arguments and keyword arguments, and we're going to go into both of those right now. So the convention here is that you have one called star args, and this just lets us know that we essentially are returning, or not returning, but passing in an infinite amount of arguments. So we can just go ahead and return args here. And let's just print what this returns. So rather than storing that in anything, let's go ahead and do circumference here. And then just like normal arguments, or non-default arguments, let's go ahead and do like 1, 2, 3, 4. And you already got a hint there that the return type was a tuple. So let's go ahead and run this and see what happens. Well, we actually get 1, 2, 3, 4 printed out like a tuple. So that means that it's immutable, so that we can't actually change anything about args. We can't add anything onto it, but we can grab bits and pieces of it. We can do everything that we would typically do with a tuple, so we could even return the length of args in here. And then maybe I'll just call this foo for now. Foo is a convention that programmers typically use just to put in like a test, an example function or something. You'll see foo and you'll see bar. Don't actually write foo in real code, in real production code. But if I go ahead and run that, you'll see the length is 4 because we're passing in 4 arguments. There's also keyword arguments. And if I just go ahead and continue with this star args here, the convention for keyword arguments is star star kwargs. So it's star star kwargs, and that means keyword arguments. And if we actually just go ahead and return kwargs, just like we returned args, when we call foo with these keyword arguments, it's essentially going to be the same setup that we would do when we are using default arguments. So rather than passing it in a dictionary, which is what kwargs is, what we can actually do is just say maybe name equals, and then we'll do Bob, and then maybe age equals 1. Bob is a 1-year-old baby. Let's go ahead and print that and see what we get. So we get a dictionary returned to us, and it actually takes these keywords, and these are the keywords here, name and age, and it passes those in as keys to this dictionary, and then the values are just what we set them equal to, so Bob and 1. And we can do anything that we would typically do with a dictionary with these keyword arguments, so you can kind of see how this would be useful to make it even more modular here with, letting infinite parameters and stuff being passed in. So let's just kind of go over just a brief example of maybe a more practical function that you would write maybe. And that would essentially be writing a function here that splits up a file name. So for example, if we have like a test.txt here, maybe I would like a function to return this, test and then text. And then here we could get the file extension and then the file name, right? So let's just maybe, define this function here, and we'll just call it like split, file name. And this parameter here that we want would be a file name here. So we'll just pass in a file name. And then really what we want to do is we actually just want to split this file name on a dot. And a dot is standard across all operating systems. It's understood that whatever the dot blah 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 is after that is the file extension. So I can actually just return file name dot split, and because Python is a dynamic language, we can use whatever string function we want on it. And what we want to split on is the dot here, and that is going to return every item in that file name that was separated by dot. So now if I just go ahead and print this split file name here, and maybe I want to just give it test.txt, and what we would expect is to be returned test and text, and you'll see that that is exactly the case here. So then we can actually unpack this now. So if I do maybe name and extension or ext, and I set that equal to split file name, and then I pass it test.text. Let's just go ahead and print name, and extension here. Run that, and we have successfully unpacked these variables. So we went through a very broad overview of what functions are, but after watching the video, you should be fairly comfortable with the basics, and I highly encourage you to practice writing your own functions in your free time and start to make more complex and more usable programs out there. So I hope you all enjoyed the video. In the next video, like I mentioned before, we're going to take a little bit of a deeper dive into dictionaries, and that should wrap up all of the built-in data types that come with Python.